Hi guys, so today we are multiplying and dividing. Yesterday we simplified, today multiplying and dividing. I know normally we do adding, subtracting, but it's actually easier to do multiplying and dividing, so we're going to start there. So you have your warm-up. If you haven't already, we remember that when we're multiplying fractions, we just multiply the top ones, 1 times 3, just 3, over the bottom ones, 3 times 15, 3 times 5 would be 15. And then we can simplify this into 1 over 5. So just multiply straight across. Go ahead and do the same for this one, and then go ahead and simplify. For dividing, we keep the first one, we change it to multiplying, and then we take the reciprocal of the second one. So I would have in this case 2 over 1. Remember that dividing is the opposite of multiplying, so we can do the opposite fraction here. So 2 times 1 would be 2 over 3 times 1 is 3. Go ahead and do the same thing here. We're going to copy the first one, change it to multiplication, and then do the opposite here. Go ahead and write your your fraction, and then simplify as necessary. Go ahead and pause the video if you need to. Take a second to do numbers 2 and 4, and then we'll come back. Thanks. All right. So for multiplying and dividing rational expressions, we have a couple of different, we're going to follow the same rules. We're going to multiply the numerators and multiply the denominators just like normal. So top and top, bottom and bottom. We're going to factor all the pieces, break it up into small little pieces. We're going to eliminate common factors. So we're going to take things on top and bottom and cancel them out, and then simplify. So don't forget that the name of the game is factor things and cancel stuff. That's our whole goal for this whole week. So if I look at this one here, this is 6 times 15 times, so that's the 6 and the 15. I have two c's, that's c squared and d squared. So I have that on the top there. And then I have 5 and 8. So I have 5 and 8. And then I have an A and a D. A and D. So I multiplied my numerators. That's good. The next step is to factor. So I started to break them up. I can break them up as much as I can. So in this case, I might say this is like 3 and 2 would make 6. And then 3 and 5 would make 15. And then 2 C's and 2 D's. If you don't need to break them up that much, that's okay. But sometimes it's helpful to do that. And then 5 is just like 5 and 1, so I'm going to leave it. 8 could be like 2 and 4. And then we have an A and we have a D. So we factored, we split it up into pieces. Then we're going to eliminate common factors, so things that are the same on top and on bottom. So I see that there is a set of 2's here that are being multiplied. I'm going to cancel those. I see that 5 and 5 can divide to 1. I see that D and D can divide to 1. And then the last part is simplify. So once there's nothing else up there, I have 3 times 3 is 9. C times C is C squared. I have D by itself over 4 and A. 4A. That is what I have here. I would also want to be careful with my denominator, just like we learned yesterday. A is not allowed to be 0, because if we put a 0 right here and multiplied it, it would destroy our problem. Same is true for D. D is also not allowed to be 0. Yeah, awesome. For dividing, it's going to be the same thing, except we're going to flip the second fraction here. So we're going to flip it, we're going to factor it, and we're going to delete some things. So if I'm here, I have my first fraction, x, just like that, 7a squared b squared times, and then I'm going to flip this fraction upside down. So I have 35 a squared b on top, and 12 x squared y on bottom. From here, I'm going to multiply straight across. So I have 18. I'm going to turn that, let's see here, I'm going to turn 18 into 3 and 6. I can always split it into more things later, but we'll see. 35, I can split into 7 and 5. I have an x, I have 3 y's, I have 2 a's, and 1 b. That's just the top. On the bottom I have 7, which is the prime number, just 7. 12 could be like 2 and 6. I have 2 a's, 2 b's, 2 x's, and a y. And I go to town canceling things that are similar, or are the same. So a 7 here and a 7 here can be canceled. A 6 here and a 6 here could be canceled. An x and an x, a y and a y, 2 a's and 2 a's, a b and a b. I'm going to see what I have left. So I have a 3 times the 5 gives me 15. Y times y is y squared. 2 on the bottom with a b and an x. B and x. That's a pretty long divisor. I don't need that whole thing. So just like this. We want to look at this step here to see what things would mean that we weren't able to have them there. So, or which numbers would make this undefined. So in a squared, a is not allowed to be 0. B is not allowed to be 0. X is not allowed to be 0. And y is not allowed to be 0 because they all exist on the bottom here of our denominator, and they would break our equation. If we put in a 0 there, we wouldn't be able to do anything. So that is how we divide. So we have multiplying and dividing. That's just if we have numbers and variables, right? We also have been pretty familiar with these. It can look really complicated, but I know that you guys are really good at factoring. So I have negative 16 and negative 6, right? So I'd say, okay, I know that this first one splits into x minus 6 and x plus 2. Right? So that's this first one here, that's the numerator. Right? I'm going to take a look at this one here. That turns into x minus 8 and x minus 8. Those are numbers that multiply to get 64, add to get negative 16. So my numerator is in green there, my denominator is in blue. I have just my x minus 8 over here, and then I see this one here can be split into 2 pieces, x plus 3 and x plus 2. So they multiply to get 6 and add to get 5. So if I'm thinking about this with all of my numerators on top, I have x minus 8, x plus 2, and x minus 8 on the top. And then I have x minus 8, x minus 8, x plus 3, and x plus 2 on the bottom. Once I have it all factored, I'm going to go ahead and cancel the things that I can cancel. So these would cancel, x plus 2, x plus 2, x minus 8, x minus 8. And I don't have anything left on the top, so it's just a 1. So I have 1 over x plus 3. Remember to include your excluded values. X is not allowed to be 8, 8, negative 3, or negative 2. All that would be my answer. Go ahead and try number 8. Don't forget to flip your fraction. So your fraction is going to start with your same one here, 12y plus 36. We have times, and I'm going to flip top and bottom here. So I have y squared minus 3y minus 18, x squared minus 12x plus 32. No changes of signs or anything, it's just flipping it over. Go ahead and pause your video, try this problem on your own. I'll be back in just a sec. Okay, we're back. So the top on this one is going to become x plus 4, x minus 4. That's the difference of squares. On the bottom here, I can factor out a 12. So I can have y plus 3 there. That's this bottom part here. On the top one here, I would have y minus 6 and y plus 3. And then on the bottom here, I would have x minus 8, x minus 4. I did all of those with the x factor, or if you're thinking in your head, this would be multiply to get this number, add to get that number. From there, this is essentially just one big long line, one big long numerator. So I'd say x minus 4 and x minus 4. It looks like that's all we can do here. So my answer is x plus 4. Oh, sorry, y'all. Looks like I made a small mistake right here. That should not be an x. That should be a y, which means that y plus 3 and y plus 3 would cancel. So I have x plus 4 and y minus 6 on top. I have 12 and x minus 8 on bottom. X, of course, is not allowed to be 8 or 4. Y is not allowed to be negative 3. All those pieces go together. All right, we have two last examples here. Notice this is exactly the same as if we had just written a plus b over 4 divided by a squared plus b squared over 4. Nothing changes here except we have a plus b over 4 times, I'm going to flip this fraction here, reciprocal, over a squared plus b squared. If I look here, I can see that I have 4s on top and on bottom. Those will cancel. And then they're trying to trick you and get you to do a plus b, a minus b, but notice that this is a plus sign. So this is actually not true. The plus sign, it has to be the difference of squares, not the sum of squares, as that would be. So in this one, we would just have a plus b over a squared plus b squared. Nothing else we can do about that. Because there are two variables, we can't tell, and they're being added. There are infinite number of possibilities, so we don't want to add a and b. There's no undefined variables, or points of undefined. All right. You can go ahead and try this one as well. Notice that this is the difference of squares. So it's going to be x plus y, x minus y. Try this one on your own. I'm going to figure it out and give you the answer. Go ahead and pause, try it. All right, that's it. You can check out paper practice 61, and then there's also an IXL available for your practice. So right here, level M N.5. Thanks, guys.